All right, take it away.
So, hello everyone. I'm here to present BlueMountain, our system to enable automated, rich, versatile data management for Android applications. So in the current state of art, what the mobile applications do is, they use both local storage as well as cloud storage to make applications better. Any application which you use uses the cloud storage in some fashion or the other. It either uses them for backing up and taking and restoring the lost data, or it uses it to share data with other users or other applications. But in the current state of art, there are way too many cloud providers for the developers to choose from. There are private clouds and there are public clouds which can be used to perform the same things. So life as a developer, if a developer has to develop one of those applications which interacts with the cloud, that he or she has to make several choices. One of them is the cloud provider to choose from. So there are providers like Dropbox, Google Drive, or even private APIs, or even bigger companies. They even have their own cloud infrastructure which they can use. None of these cloud infrastructures have a similar interface or a similar semantics. So there are various consistency models to consider, and security and permissions and data integrity which the developer has to consider. So reasoning out of these various consistency models and then manually choosing them is a difficult task for the developer. So these are generally tangential and repetitive. If a developer develops 5 applications, he has to probably do this, iterate over the same things again and again, and these applications might not have the same needs as well. So the developer might have to carefully choose which cloud provider to use for which application. And as I mentioned, these have incompatible interfaces and semantics. It's not very straightforward. There's no one-to-one mapping, say, to move from Dropbox API to Google Drive API or to a private cloud API. And also, if a particular application uses Google Drive, it generally binds that application to Google Drive. And if at a later stage, if Google Drive changes its APIs, or if the application developer or the user does not want to use Google Drive, he or he has to rewrite the entire application because the application logic and the cloud logic is so intertwined that it makes it difficult. So now consider life as a user. For a user, because the developer has made so many choices for the user is generally constrained with the choices made by the developer. So if I, as a user of, say, Evernote, I want to use Google Drive and someone else wants to use Dropbox for the same application, we are constrained by what the developer of Evernote did. And the Evernote developer uses his private cloud, which is on the Evernote servers. So there are privacy concerns. So consider a corporate environment where you want to use a particular application, but you are not comfortable with that particular application residing on the public cloud. So this is something which the user can't fix. Any changes, the user has to go back to the developer. If the application is being used in Microsoft and the developer has chosen Google Drive to store all the data, and Microsoft wants it to be changed, Microsoft has to contact the application developer and ask him or her to change it to their own cloud. So in this case, user has to always go back to the developer. So now consider a fast forward with BlueMountain, what we envision as a system. So let's consider this Android application. And for now, let's see the BlueMountain compiler as a black box. So let's pass the Android application through this black box. So now it's going to spit out one of those 2 applications on the right side. So the one on the top is the same application as we see on the left, but which has the ability to take backup on Dropbox. Let's say you develop a note-taking application similar to Evernote, and you do not have any cloud features. And you treat everything as just local storage by making POSIX calls or database calls and so on. And then you pass it through our black box, and then it's going to spit out another application which is the exact replica of what the developer intended to do, but which now takes backup to Dropbox. In the case below, that's the lower case, where instead of Dropbox, we are taking backup to a secure private cloud. If I have a private cloud in my lab and I want all the applications or I use to take backup on that particular cloud, we can feed in the APIs of that particular cloud to the black box, which is depicted in blue, and then it's going to spit out what is in the right at the bottom. That is one scenario, which is a simple backup scenario. Now consider a peer-to-peer sharing scenario. If you are hanging out with your friends in a particular location and take a picture, you want to share it with your friends. So in the current state of art, the only way to do it is it's going to go to the cloud, and then from the cloud it's going to get synchronized with the friend's mobile system and so on. But then we are envisioning a system where you pass, let's say you write a camera application, you pass it to the BlueMountain compiler, and then it's going to spit out another application which now has the ability of peer-to-peer sharing. That is now, if your friend and you, both of you use the same application, as soon as you take a picture, instead of storing it locally, it's also going to transfer it to your friend's mobile. So what are the goals of stating the goals formally of what we are trying to do? We want to reduce the development time of any developer. The developer has to just concentrate on the application logic and worry less about how it is stored, the security, the consistency, and so on. And the developer should not worry about the cloud semantics. One of the recent examples I can quote is just a few days back, Dropbox released version 2 of it, and where they no longer support data sync and database APIs. So these changes should not affect the developers. So developers should not be constrained by these things. So another thing is it's always easy for any developer to treat all the data operations just as local operations. So it's not shared. The developer need not bother about when to back it up, what to do if the file is lost, and so on. But just go ahead and treat everything as local. So we want to virtualize the storage operations. What do we achieve by virtualization? After virtualizing, we want to augment a particular storage call. Let's say you do an open on a file. Other than opening the file, we want to do something else. So this is what we call as augmenting. So we want to use something else, and the last goal is we want to make this post-development. That is, you develop the application without worrying anything about BlueMountain, about backup, sharing, any of these things. After you develop an application, you have the app binary, you change your mind, you want to go to a new cloud or you want to use a new service, and you use it. And we have some additional restrictions too, which is we do not want the framework to be modified for this at all. Modifying the framework is one architectural approach, but then this comes with the baggage that it's very hard to deploy. If I modify the framework, I can't give my application to you and ask you to use it unless you are ready to tweak with your ROM, with routing your phone, and so on. So with the ease of deployment, we do not want to do that. And we want to do this without accessing the source code. So this is not just a tool for the developers. We also want this to be used by users. So the assumption is users do not have access to the source code, so we want all the features to work even if the user does not have the access to the source code. And the system should work with the existing apps, that is, it should have backward compatibility. So before I get into the how we do this, we have to understand how exactly Android stores files when it is treated locally. So Android generally has 3 ways of storing local data. The one is the files, which is regular POSIX interface like open, read, write, and so on. Other one is the key value store, which is also called as shared preferences in Android, which generally saves user settings and other preferences. The last one is the database. Android currently uses SQLite database, and there are what this tells us is there are a limited ways of storing data in Android. There are multiple ways of accessing each of these, but then still it's limited and it can be enumerated. There are other ways like content providers, which third-party developers use and other developers can use for storage, but we are restricting ourselves to these 3 ways, which is more often used. And how do we solve this? So we create a framework which automatically integrates cloud storage to the Android applications. So what we give is a tool which rewrites the binary, that is by tapping the storage calls. So we capture all the storage calls with respect to the 3 ways of accessing data I mentioned in the previous slide. And we're going to give a tool to rewrite the binary. We also have a runtime which runs in your application as a normal application. So it does not need root or any modifications to the framework. And this runtime is essentially responsible for negotiating with the cloud and managing various policies. So different applications might have different policies, but there's just one runtime which works as a regular application and manages all of these. And how do we do this? We take the Android application, we decompile it and do statistical analysis on it, and correctly identify all the storage related calls. And the way we do it is, like I said, there is a limited way of accessing data. We enumerate it and we access it. And here, now I'm going to explain the system architecture going into in-depth of how exactly we do this. In the left, we have the APK, which is fed into what we call the BlueMountain compiler, where there's a record transformer which is going to decompile it and analyze it using soup. And we have a backup library which can be used. So now we have it's going to throw out another application to the right, which is a smarter note-taking application, which is instrumented. And now this has the application of the green box has the ability to trap all the storage calls and then multiplex it. So you can see here it's also writing to the data, it's also writing to the local storage as well as sending a notification to the BlueMountain manager, which is the runtime I mentioned about. And the data is shared between the runtime and the application through the shared cache, which is in the SD card. So once a notification is sent to the manager has done all the negotiations. In this example, I'm using Dropbox, so it's gonna negotiate with Dropbox and it's gonna upload or download the files. So if the application in the green box detects that a particular file is absent, it's going to contact immediately the manager, and the manager is going to download from Dropbox and give it. So there are certain challenges involved in this, wherein sometimes for an application to just boot up, you need certain files, particularly the user settings. So at the start time, we also have a way to check if all the user settings in the local storage are up to date with what is present in the cloud. If not, the startup is delayed so that the latest data, the latest user settings is fetched, and only then the application starts up. So how do we do the storage virtualization? So this might appear like, because I mentioned that there are we can enumerate and there is a limited set of operations, this might appear as though it's just a search and replace which can be solved by a grep. But then it's not so because of an example to the left. So here in the example, the my file output stream extends the file output stream, and because of this polymorphism, what we see, we do not know where exactly to tap the calls. So in the example here, after the bytes b equal to 10, we don't know if we have to tap the application here or we have to tap the application in the overridden method. To do this in statistical analysis, we have wrappers around. This problem can be solved by modifying the framework. But like I said, we do not want to modify the framework. So we have wrappers around file output stream to solve this and correctly identify the points. This is one of the most challenging parts of automating and identifying the right places to instrument. And there are various other challenges which I'm going to talk about. The first is the cloud APIs. So most of the cloud APIs are object-based APIs, and they have a CRUD interface. There are other alternate APIs like the Dropbox Sync API, which makes it easy for the developer to treat all the cloud data as though it is just a file system, and it's going to do the backend work by the client side as well as some code on the storage to make it easy for the developer. And there are other applications like Google Real-Time API, which is meant to write collaborative applications. But all of these use the basic REST interface and the CRUD, and which remains the common interface. So what I mean by minimum common denominator is it's easier to map the CRUD and the REST interface of Dropbox and Google. It's easier, not straightforward. It's easier to map than say Dropbox Sync API and Google Real-Time, which are completely different. Then there is an interface mismatch of translating these object calls. So if I use a REST API, it's just going to be get and put, whereas a DB might update an individual row. The entire database is stored as a file in Android system, and any update to a particular row results in updating the entire object on the cloud. So that's the interface mismatch which we have to deal with. One of the solutions we can do for this is to break the object into finer chunks. That is, a database object can be broken into 5 or 6 chunks, and each of them can be stored on the cloud independently. There are semantic mismatches too, which is essentially saying that there is consistency mismatch, like the Google Real-Time APIs guarantees a real-time consistency, whereas Dropbox or S3 just gives you an eventual consistency, and so on. And this can be solved by getting some additional input to the developer. So in the ideal case, we want a zero effort from the developer, but in some more advanced use cases like this, we can get some input from the developers, which is going to make our system more efficient. There are a few related work in this area, not particularly in automating the cloud storage, automating like what we are doing, but there is a lot of work in the area of combining the local storage.
That's 15 minutes.
Okay. Combining the local storage with the cloud. So the first one is ViewBox and Simba, which provides fault tolerance and consistency guarantees and between cloud and local storage. Symbiosis is a system by Microsoft which does selective sharing of objects, selective sharing of files. And then there is Procrastinator, which is again developed for the Windows platform. It rewrites the binary to reduce the traffic movement due to caching. This is probably the most similar system like ours, but then their goal is to reduce the network traffic, whereas we try to introduce backup and sharing features into the application. Then there is Metasync, which uses cloud services and modifies some code on the client side to enhance some of the guarantees it gives, like consistency guarantees and so on, by implementing paxos on the client side. So in conclusion, we have explored instrumentation as a way to automate storage services and give the ability for apps to access the cloud automatically. We have a prototype which demonstrates the power of automating the storage, of automating and creating storage virtualization. And in the future, we want to deal with the application instrumentation challenges as well as resolving some of the consistency and interface mismatches, which I explained in the challenges section. So thank you.
17 minutes.
16 and a half. Okay, question? Sure.
I have a question about the mapping. So for example, if I'm a developer, I write an application using the Dropbox API, and you need to like convert it into the private cloud APIs. So it's like the mapping which exists is from many to one. Right? So what my question is, if on the long-term run, if you like deploy it, there'll be like many cloud providers.
Right.
And maybe you would like have to increase the number of private cloud APIs. Maybe you want to like have like 2-3 private clouds. So won't the BlueMountain compiler source code every kind of mapping?
Right. So that's a good question. So the answer for that is the compiler is not one that fits all.
Let people finish the question.
Okay.
Right. And don't talk during their question.
Okay.
Just let them ask the question and wait until they're done. Don't talk over people. People hate that.
Yeah.
It'll make them mad, and then they'll take it out. Just don't do that. I know it's hard to be patient. I know you're amped out because you just get them to talk. Just shut up. Let them finish their talk. And then like let a moment pass, because then it actually looks like you're thinking about the answer, right? Rather than just giving them some sort of pre-programmed answer, which might be what you're doing anyway. Right? It never hurts to actually pause for a minute and actually look like you're trying to think about it. People like that too. Do you remember what the question was?
Yes.
Okay, go ahead.
Yeah, so the answer to that question is, it's true that we have to change the compiler when you move to a different private cloud. But the point here is, if you are using a private cloud, you probably do not use a private cloud for one particular app. So once you design a private cloud, you would want hundreds of apps to be stored in that particular cloud. So it's a one-time effort still to develop the compiler. And secondly, what we have explored currently is a mapping between local storage and cloud. So like what you mentioned, you are mentioning a case where a Dropbox, an app which uses Dropbox, has to be changed to an app which uses the private cloud. That is something which we plan to explore, and we do not have that in our prototype. However, what we have is, if the application uses only local storage, you can move it to a private cloud, but then that requires some effort to redevelop the compiler for each private cloud.
Yeah, so my actual question was like the scalability of this Blue Cloud compiler, right? If you actually deploy it and people start using it. But every new private cloud that needs to be incorporated, the Blue Cloud compiler is going to like increase exponentially in its source code size or whatever the logic is supposed to use.
Right, so the BlueMountain, so everybody who has a private cloud and wants to deploy it will have a different version of BlueMountain compiler. So it's not like BlueMountain, you feed it and everything is done automatically. It's an infrastructure which has to be modified for your particular private cloud.
Okay, makes sense.
So, Sure. I mean, the previous answer was okay, but I think you gave more of the peripheral advantages first. So you went through this whole piece about REST API and CRUD and so on, right? So if somebody provided you sort of the lowest common denominator API, it doesn't matter, like if it's a different thing, right? So the reason why you reason about this is to say you provide me with sort of this basic implementation. It doesn't matter if you're Dropbox or Google or private cloud or whoever, you can now interface with them, right? Because you have an understanding of what the semantics are without the actual API, right? So that would be the first answer.
Right, I don't understand. So the question, as I understood it, was, is this going to make it difficult to support private clouds? I would say no, assuming the private clouds all don't have their own private interface. Why would every private cloud have a different interface? Right? I mean, they're going to be running similar software. The privateness of the private cloud, Jerry, is not like that they're all exporting to interfaces, just that they are sort of isolated from other things that would be considered the cloud, right? So like if 10 different companies set up their own private clouds, they're not going to use 10 different interfaces. Right? They'll probably have 2 different interfaces. Right?
Maybe like
they're going to be using like common software to run those private clouds.
I mean, they
maybe
might
like
have.
one cloud service, like one private cloud would be like an enhanced version of the previous private cloud.
Yeah, but you don't break interfaces like that. You try to keep those interfaces stable across.
Okay.
But also, more importantly, the lowest common denominator is always exists. So I want to read and I want to write, right? So, and what do you call what CRUD is basically create, read, update, and delete, right? So so the basics, so the bottom line exists in every place. And as long as you provide that API and we have some semantic way of easily saying, okay, this is what create, this is what replace, right. Then you can interface with that. It doesn't matter.
That didn't really. Well, let's finish the questions. I mean, I think the big.
One more question.
I had one more question.
Yeah, go.
You also said like users could also use this BlueMountain, right? So I didn't understand in what way it could benefit the users.
So let's say you have, as I mentioned in the example, there's a note-taking application which you like to use. But then let's say that note-taking application is writing only to your local storage. So for example, WhatsApp for some reason does not take backup of your messages in the cloud. But you want your messages to be backed up, and you also want it to be backed up to your own private account of Dropbox. So because Dropbox is a very popular service, we can provide BlueMountain compiler, like we already have a prototype of BlueMountain compiler which uploads to Dropbox. So you can use that out of the box and recompile WhatsApp application what you download from Android Play Store. So you get another version of WhatsApp, say WhatsApp Dash. So now WhatsApp Dash is going to take the backup of all your messages on Dropbox into your private account. So now the WhatsApp developer has no access to it, and you're going to trust.
I think this use case is very, very tenuous. Right? I just don't. I wouldn't talk about this. I think that the rest of it's fine. I just don't see this happening. Right? Most users are not going to use some sort of tool that is binary writing of an app. Right? They're just not going to. So I just like this is like a use case that involves like an incredibly skilled computer scientist, right, who wants to use this, right? This is just not a normal person, Charlie. We're not talking about a normal person anymore, right? So I wouldn't describe this. I mean, is this possible? Yeah, but you need to talk about it in a way that doesn't assume that some super user out there is going to do this, right? It's just not going to happen, right? And then, of course, you have problems because you don't know anything about how the app works, and so the app changes its data format. You try to install a new version, you've broken all of its data, right? So I just think there's, yeah, I don't know. I'm not totally convinced by these.
Speak about like when you showed this note-taking app and the way it goes through. So that hole was bumbled a little bit. So you didn't say anything about note-taking, and suddenly note-taking showed up. But also, what I was hoping you would say was not that the user runs the BlueMountain compiler, but because the developer already did, the user now has the configurability. I can say I give in my login password for Dropbox, and then it goes to Dropbox. I give in my login password for Google Drive, and it goes to Google Drive, right? So that's the configurability that you can provide to the user, so he can pick and choose whether it's private cloud or something else. So not that person runs another compiler, which is a little more tenuous, right?
I mean, I think more likely is that somebody would do this on users' behalf and provide versions of these apps that use these various cloud storage. But then I also, again, do I really, anyway, I'm not sure I really care as a user where that data ends up necessarily. It's going to end up on a cloud storage provider. And again, once you start talking about users provisioning their own storage for these types of apps, I think that's a lot more tenuous, right?
But you might care if it's encrypted or not encrypted, for example, and that's an option that can be provided by wherever it goes.
Sure.
Or do I need to create a box account just to use some note-taking app that
that's fair.
exists? I mean, by the same token, then if why would the developer necessarily buy into this? It seems like from the developer's perspective, it would be much more reliable to work at the source code level than to work at the binary level.
So I think because of the changing interfaces of the cloud, the most important thing we are trying to solve by automating is to reduce the repeatability. So if a developer is developing 10 applications, and if for some reason the developer decides to move from local storage or deploy the previous applications which he has developed only for local storage to cloud, it's generally repetitive to trace the same flow and...
Sure, but then what does the compiler buy you? Why does it make sense for me to rewrite the binary rather than rewrite the source? I mean, as the developer, I presumably have access to the source code. Why build this rather large and extensive infrastructure to manipulate the binary when it would make much more sense to do this translation at the source code layer?
Yeah, it's a question you'll get again and again.
So again,
Sorry. No, I want to hear your answer.
So like Jeff mentioned, it's probably some super user. What we see, what we had in mind when one of the use cases was a corporate environment where somebody on behalf of the end user is going to do. So there is an entity between the developer and the end user who's going to do this. So we don't see really normal users doing it, but.
So this might actually be a good place to kind of go provocative. Pitch it as take back your freedom. Take back your freedom to use to control your data from the iron grip of Android.
Slaving you.
Yeah, exactly. Well, I mean, look at
from one of James's thoughts.
Got a
confining you to these cloud things.
There you go.
You're shackled to the cloud, one particular provider.
You got a poster upstairs that has part of a snippet from the Dropbox API, the Google Docs API, and it's like, Google reserves the right to use your data however they feel like. It's not your data anymore. Take back your...
Well, okay, but like, to push back on that, right? Like, giving me the choice between choosing different cloud providers to store my data is not necessarily...
One of those
cloud
might
be a
providers
private
could
thing.
be Diaspora or what is it, Open...
Yeah, one of those implementations that's
There's
Cloud.
always a trust boundary there, right?
Well, Open Cloud is you run your own server.
Again, now you're talking about weirdness, right?
Sure, I mean, at that point you're...
I mean, either you're that particular and you go take the time or you don't, right? So there are only two options.
No, but I think, so what I would suggest, and we can go through the slide track if you want to back up, but I mean, to me it seems like there are two branches that lead to sort of what I would consider four use cases for the system, right? One choice is, am I moving, and I think this all gets muddled up in the presentation. I think it would be better to separate these out and talk about them separately. So the first question is, am I moving local storage operations to the cloud? Or am I just moving cloud storage operations between different providers? Okay, so that's one choice, and I think you can kind of do both, right? And then the second choice is, oh wait, I did have two choices, right? So because there it's a question of, in the first case I sort of Oh, okay, sorry. So in the second case, it's am I rewriting the binary, or am I providing a better interface for developers to use that's more cloud agnostic with respect to how to use cloud storage, right? And so it's sort of, again, offloading local storage versus moving around cloud storage, and then developer assistance or not, okay? And I think, you know, if you talk about those use cases a little bit more clearly, it will make sense sort of what things need to be done, right? Because on some level, one of the contributions seems to be this compiler, but then you talk about developer support. And I think the thing that makes me really nervous about the system is I think there's no way, or it's going to be very, very difficult to capture the semantics of storage that will allow you to do this efficiently, right? Particularly when you move local storage to the cloud. Now, if you just move cloud storage around, right, then that probably works better. But when you're moving local storage to the cloud, I think there's going to be a huge performance penalty if you don't understand what you're doing. Right?
And a correctness penalty.
A lot of redundant data traffic, right? So that needs to be addressed, because I think it's going to jump out at people. But the idea of providing a better interface that's a little bit more general for allowing developers to write applications that are cloud agnostic, right? So I can write an application in a way that allows the user to, like when they install it, say, you know, where do you want the data stored? Right? Dropbox, you know, Google Drive, whatever, right? On my own server that provides a particular interface. So I think if, you know, that seems to me what you guys are doing, right? Part of what's coming out of this is this better interface for accessing cloud storage. It's trying to generalize features of cloud storage systems while still providing enough support for the way that Android applications use storage, right? But I think, again, if you separate those two out, it'll make a little bit more sense. Because, you know, if, for example, in the beginning, you made this claim at one point, which maybe was just, you know, just something you said that you didn't mean, but you said, well, every app uses cloud storage, right? And then at the end you said, this is a way to get your apps to use cloud storage. So you just told me at the beginning, they already did, right? So it seems like...
There are many of these though. You said something like real-time consistency, I don't know what that means. Like what is Google real-time and what is real-time consistency? There doesn't exist anything like that. And this is a hot storage crowd. They will be like, what are you talking about, right?
But I think from a high level, you know, the goal is, the goals are different too, right? I mean, for example, particularly when you look at the developer versus no developer support case, right? In the no developer support case, the goal is don't break the app, right? And don't make the performance suck. And I think you're gonna have a hard time with those things. With the developer case, it's a little simpler, right? It's kind of, can I provide a general enough interface that allows developers to write apps effectively while still using a bunch of different underlying storage, right?
So
I think
why did you
separating
not
those
talk
out
about
allows you to
runtime?
focus on those two.
There's a runtime, right? So this whole this performance issue would have gone away, well, not gone away, or you could have at least avoided the question by talking about the runtime. Like there was no discussion of that at all.
Yeah, what's the runtime?
Yeah, so it's like...
I mean, I don't think the performance issue is going to go away, right?
Yeah.
Particularly when you're doing it without developer knowledge, because again, I have all these rights, and like the application may not really care that a particular object is consistent until a certain point, right? You just don't have, without those semantic cues about consistency, you know, you end up just having to like blindly try to push all sorts of data to the cloud that may not need to go, right? So I think that's a big challenge, and I think that needs to be acknowledged in the talk, right?
To say nothing of resolving.
Right.
Consistency.
Right, yeah.
I brought that one up to you guys before.
I told you should say this.
It's a hot storage talk, right? Like the point is, like the first half of the talk should be, this is awesome and how great it would be. And the second half of the talk would be, here are all the hard problems we have to solve to get this to work. And if you don't acknowledge them, people are going to think you don't know about them, right? And some of them are really glaringly obvious. So if you don't acknowledge them, people are going to think people are never going to get this to work because they don't understand some of the fundamental challenges to what they're trying to do, right?
Yeah, this needs a fair amount of rework. One, better description of the system, like describe just running through the compiler is great, but now at runtime you provide a service and does offloading and so on. It is little better support for what happens when you are in disconnected environment or whatever, right? And from the beginning of this paper, I've been telling you, the consistency issue will be there all through. You have to acknowledge it and put your hands up and say, yeah, we don't do anything at this point, we do a very simple thing, and this is one of the major things that we hope to do things on. And have something more intelligent than that to say, right? So show that there is something to be done, right? So that is, so go one level deeper and say, yes, we only guarantee eventual consistency, but we will have some use somewhere, right? So we will have these deadlines or something, right? Otherwise.
But the other thing, I mean, the other thing that I worry about with it, that's sort of correctness related, right? Is again, some of what you guys seem to be claiming is that I can take local storage operations and map them onto the cloud, right? But there are huge differences in particularly the performance and latency of those operations that you're exposed to the app, right? So I have an app that I've written and I've tested that uses local storage, right? Those local storage operations have extremely predictable behavior because they're accessing local storage. Now, do they all, like, is it completely predictable? No, right? But they do put the latency down. They're very tight. And they don't necessarily change a lot over time. Now you're moving those onto the cloud and you expect the app to continue to work, right? But I think what you're going to find out, and we, like my group has talked about this, and I had a student who was trying to look into this, I think you're going to find a lot of apps are going to break, right? Because there are races that you're going to expose when suddenly the read, the last time I did a read operation, I completed really quickly, but then the next read operation hangs because you're waiting for it to hit the cloud or something, right? Or, you know, like the data doesn't get to the cloud as fast as I thought, whatever, right? So I think there's a lot of correctness issues, particularly when you do this automatic rewrite. But I think if you also point out that you're trying to develop this cloud agnostic interface, that gives you a place to stand if people really come after you with the blind sort of rewriting stuff. Because I think that's the most tenuous part of this project, right? That's the part that I would predict has the least success if actually moving well, without a lot of work. Right? The cloud agnostic interface is great. Okay. You guys have any other questions? All right, Anudipa, it's your turn. Leave the camera on. Just do the whole.
Oh.
Both you guys have these unreadable
Yeah.
author lines. You guys Sharath, you do the same thing, right? Like, it's not like there's a lack of space on this slide, right? Just make the top bigger. You don't have to fix it right now, I'm just saying.
Oh, 14, really?
Yeah,
Like,
I think this is even worse.
Yeah, I don't understand this
So this is a talk where the moment is DC, it's 10 minutes?
much. Yeah, but it's nowhere close to 10 right now.
Okay.
It's much above.
Okay.
But I'm like confused about what I should get rid of it because This is like a proposal overview talk,
Right.
but
Okay, well, okay, we'll give it and we'll see how bad it is. How long is it?
it's pretty long.
Okay. You ready?
Don't worry about it.
Okay. Hi, I'm here to give an overview of my proposal, which is titled Flexible and Effective Energy Management in Smartphones. So, we know it's pretty obvious that the most important feature of these popular personal devices is mobility. But if we end up having our devices plugged to the wall forever, then mobility kind of becomes a moot point, and this makes energy management a critical field. And it is also pretty well researched. There has been decade-long worth of work, and it's still ongoing, about how to get accurate measurements, how to build robust power models, get better mechanisms to effectively manage energy, and so on. But even though we have all these awesome research tools, the real world is kind of presents a quite different picture. The dissatisfaction among real users when it comes to energy behavior of the devices is pretty real. But that brings us to the question that why is it still an unsolved problem? Maybe because the most common approach in all these solutions is the fact that they are geared to this generic sense of a generic user or a generic application, which is quite away from how a real user uses their phone or how real applications consume energy. We have seen a pretty wide diversity in terms of user behavior and energy behavior when it comes to these phones, from a 2-month-long study at our test bed called Phone Lab located at University at Buffalo. So we collected battery traces there, and we saw that there is a quite big variation when it comes to how users use their phone. Some users use their phone way much than others. Even for a particular user, there are dull period and peak period when it comes to using their phone. Here we are saying that, okay, if there's a high discharge rate, most probably the user is running heavy applications. And it's not only about how the usage diversifies, but it also questions this assumption that users only charge their phone when their battery is low. Usually your Android system says 15% is the low battery notification trigger level. But here we see that users often charge their phone when the battery charge is 50% or 60%. And energy is such a resource that cannot be carried forward. So once you charge your phone, then all that 50% of energy or battery charge that you have stored, it gets lost, which you could have used for bettering your performance. And it's not just about the energy behavior of the whole device. Even applications, they behave quite differently when it comes to energy consumption. Most of these apps have like a background component that runs and fetches latest updates and notifies the users. If we look at the percentage of total energy consumption contributed due to this background activity, we see that there is quite a huge variation. Apps like Google Search, Twitter, they spend 60 to 80%, like they consume 60 to 80% of the total energy doing background tasks. And this is hard for the user to relate to because users see, okay, I'm using the app and it is draining energy. But in this case, a lot of energy drain is happening when I'm not interacting with the device. Again, lots of researchers believe that app developers should be the one to decide how to tune their performance in order to be more efficient, energy efficient. But when we looked at the popular apps about how they consume energy when battery level is below 20% and above 20%, we see that there is not a lot of difference. Maybe either because they don't really care about efficiency, or maybe because they do not have enough information or tools to make an effective change in how their app is going to perform without completely degrading their performance. Now, this diversity suggests that we need to have different policies. One single solution to solve all these various energy expectations and energy behavior is not going to work. And hence, we need flexible flexibility in our operating system to handle multiple policies, which is currently lacking. Now your Android system, it has a single policy embedded within it, and that kind of has a single strategy and which manages how energy will be consumed on a device. In order to address flexibility, we came up with a tool called Jouler, which is a framework embedded within the operating system. What it is supposed to do is that it is going to expose measurements like app usage measurements or energy consumption on a per component per device basis, as well as mechanisms to control energy that are already embedded within the operating system. We're going to expose both the measurements and the mechanisms to the app space so that app developers can now write apps that implement policies and publish them in the App Store. Users can just select apps which matches their personal energy goals and install it. They don't need to know how those apps are going to manage energy, what mechanisms it follows. They just need to look at whether, okay, this app will ensure that my battery lasts for 14 hours or 15 hours, so I would rather use this. This app sees that, okay, it makes sure that the apps I like most uses most of the energy and not while throttling performance of the apps I don't usually use, so I'll use this policy, and so on. Now, after addressing, so we have all these, multiple policies to address our different expectations, but are these policies well armed? Do they have the information they need to actually effectively control energy? Now, one would say that we have energy measurements, which is pretty accurate. Isn't it not enough for these policies? So we can try to answer some simple energy consumption related questions, which are pretty important for any basic energy management policies. For example, when it comes to comparing apps, currently battery settings in your Android is going to show something like this. App A consumes 31% battery charge, App B consumes 21%. Given this information, can you make any comment about App A and App B, say in terms of efficiency? Is App A more efficient than App B? It's hard to say without knowing what these apps are. For example, one can be a video chat client like Skype, and the other can be a note-taking client like Google Keep. They have very different features, they have very different goals. And obviously, a video chat client will be more energy exhaustive than a note-taking, sticky note app. What if I make the comparison easier? We say that both are music streaming apps. Then can we make a comment on the energy efficiency? It's still hard because one of the apps may be streaming songs from over the network while the other is playing offline playlists. Hence we see that comparisons, though are very basic, they're pretty hard to make for apps belonging to different categories, or be it apps from the same category, or even for apps for the same app across different users, because different users may be using different features and so on. So this brings us to this statement that energy management is not equivalent to energy measurement. Energy measurement is definitely an important part of management, but energy management does more. For example, energy management policies should be able to control resources in such a way that the battery extends for an expected lifetime. Again, if the lifetime is fine, if one is fine with the lifetime, then how can it make control the performance? Allocate resources, better resources to maybe apps you prefer most, better the performance of the most preferred apps by throttling performance of least preferred apps, and so on. To do all these more sophisticated energy management choices, we need more information. Energy consumption by itself does not make the cut. In place of this missing numerator, we suggest we need a way to quantify how valuable an app is to a particular user at a given time. If we can have that information, then coupling it with energy consumption can give us some idea about the energy efficiency. But then one may ask, how does it help? If you know about the energy efficiency, then we can compare these two apps with each other based on their efficiency without knowing what these apps are or which category these apps belong to. But then comes the question, okay, there is an app value, but does it really exist? In order to find that out, we can do a very quick and simple thought experiment. I'm guessing all of you here would have smartphones and would have installed multiple apps. Let's say I give you an ultimatum that for next 2 days you only get to use your phone if you allocate some quota of energy to the apps you want to use in such a way that if that particular app uses that particular quota, then you don't get to use that app anymore until and unless you charge your phone again. Most probably all of you will be able to do that. For example, I use Facebook and Gmail more often than not. So I might be allocating 30% of energy to each of these two apps, while maybe allocating 1% of energy to all the other apps that I have, to each of the apps that I have installed, because I don't really care if I get to use them or not in the next 2 days. So we have an intrinsic sense of which app is more valuable to us than others. But then it brings us to the question of how do we measure this value? And that's a very hard question. And we tried to make some attempts in trying to find out how to measure this value. We said that, okay, these apps interact with users in form of some content, be it visual or audio. If we can quantify this content, then we can find out how much content a user is consuming per joule and make that into an efficiency metric. Initially, we tried using screen refresh rate as a metric for measuring video content and sample rate or audio beat rate for audio content, where we assigned more weightage to video content over audio content, saying that to provide video frames, you spend more energy than to play audio. But we didn't find a very conclusive result, which showed that most probably our way to quantify visual and audio content was just too simple. So in our next step, we are going to better our metric by trying to look at the percentage of screen that is drawn, look at what kind of interactions user do, like a click or a scroll, and then each of those interactions, how much of the content, visual content is generated due to each of those interactions. We also want to look at the frequency of the apps in which apps are launched, or for each session, how long each app session lasts, to understand whether it's something that the user always uses or would notice if the performance is degraded too much, and so on. After we create our version 2 of the content metric, we want to do a survey for among our phone lab users to see whether the least valuable apps identified our metric goes along with user perception of least valuable apps, whose performance they will be willing to degrade in order to have better energy behavior. And it's not just about applications. It's important to look at how users use these phones. Is the app usage of a user differs based on a time of day, location where they are, battery level that are already existing. What triggers battery charge? Can we predict it? Can we say that, okay, for this particular user, this is the trigger that would be followed by a charging event? So what we want to do is we want to find trends and correlations between all these different parameters that can answer the question of how users' app usage behavior differs with other contexts. Like differs with location context or time context and so on. So that later on, those relations can be used to build a model and can be fed to these energy policies as another input to decide on which strategy they should take. And to evaluate this, we would like to build a very simple system of low battery notification to see whether we can predict, based on these correlations, what is the low battery trigger for end user. And if that results in a successful charging event or not. And that brings us to the close of the proposal. Any questions will be welcome.
So it's only about 5 minutes.
Oh.
Not too bad.
So, like Jeff said, the font size, you definitely,
Yeah.
most slides are half, I don't know why.
Yeah, no, the slides suck, like the slides
I'll get
need
it.
to be
So
fixed.
go back to the first graphs you had. I think maybe you've seen these graphs too many times. You should explain what I'm seeing.
Okay.
The significance might not be obvious. I mean, it's not obvious to me. I know I've seen similar looking graphs many times. But you need to explain to me what X, what Y, and why it's making the point you're trying to make, right? So a little more detail.
But I think in general on an event, this is structured too much like the workshop talk you gave at Humboldt. For a DC talk, like I would appreciate if I was on a DC, I want you to tell me what you're going to do, right? I want a large portion of the talk to be, so the point is to get feedback.
I mean, I would say what the contribution is. So I think the part where this app value and emphasizing that, so showing the emphasis.
No, I know, but the point, again, I mean, I think the point is to get feedback from the people on the DC, right? So the point is like, here's what I think I'm going to, like, you want to set up the research question so they know what you're doing, but then I think a larger portion of it should be, here's my plan, right? Here's the experiments I'm going to run, here's, you know, and then, because then they can, that's something that they can grab onto and say, well, this is, I would do this differently, or I would, like, that's what I would do, right? I mean, I think that, like, if the more concrete you can be about sort of, again, and this is important for you to do anyway, right? Because you want to graduate, right? So this is like your 1 year plan, right? Like how I'm going to get from where I am now to a year from now having a dissertation that starts to address some of these questions, right? So one thing, and you didn't really talk too much about Jouler, which is fine. One thing I kind of feel like if I was structuring this, one thing I might say, given the work that you've done, right, is, you know, look, energy management is still a problem on these devices. You do, I think the mobility argument is kind of a nice way of motivating that. I've always liked that, but I think I would push that a little bit harder. And then you say, we've done a lot of work on energy measurement, but we need to, but that's not equivalent to doing energy management. I would do that earlier, right? What do I need to do energy management? Well, I think there's a nice sort of classic policy mechanism split here, right? I need policies to manage energy in ways that respond to the diversity of users. So that's where you can bring up the diversity. And then I need to expose mechanisms that allow those policies to control energy usage on the phone. That's where I would say, I've actually done that part, right? I built a system that does this, right? So we have a system running on, that way we can run on our phone app devices that allows us to do the policy level experimentation, right? And you don't need to dwell on it, right? But I think it's just nice for people to understand where you are in the process, right? So, okay, so I solved the mechanism problem, right? We have a nice system for doing this. Now, there's this policy question, right? And that's a really sort of juicy question, right? The mechanism part, I think, is less interesting, right? So I wouldn't dwell on it, but I think you just want people to know that you've done it. Now I'm at the point where I can write, you know, you're at a great point, right? I mean, you can write these policies and deploy them as apps. And give people a chance to use them and rate them and experiment with them and see what happens. So now, you know, and then you sort of shift into talking about what do we need to do to write better policies. We have measurements as an input. What else would we need? We have value, and then you can sort of segue into that part of the talk, right? But I would probably spend the last 2 minutes at least saying, you know, here's a concrete plan, right, for what I want to do, right? You talked about some of that, right?
Yeah, I didn't quite.
You know, improving the content efficiency metric, you know, things like this. But I would really kind of say, this is what I'm going to do. Here's how I'm going to evaluate it. You know, here's what I expect, right? I think at some point you might need to do a user study, because I think that it's going to be hard to sort of, it's going to be hard to quantify all the effects that some of these policies will have. But I think it's okay. There's a little, like, I think I would just restructure it a little bit, and you'll find that some of the stuff that you've covered will sort of fall out. It's not really needed, right?
Okay, like, I think
Okay,
if you want, yeah, why don't we go, you want to go through the slide?
So before that, the only comment, which is maybe slightly different from what Jeff said, For me, in a doctoral colloquium, what I would like to see is like the overall plan. So here is my thesis, the overall hypothesis, and pieces I've done and pieces I have to do, and elaborating the pieces you have to do is good, but also the central hypothesis I'm saying, so I think the slide on Jouler where you didn't spend a lot of time, I would like to have understood better what you've implemented and what mechanism, what that allows you to do, right? So I think we need a new energy management framework, okay? So what components does that have? I have this now a nice setup for experimentation. I think there needs to be multiple policies and we're going to experiment with many of these things. So I've built sort of this experimentation platform, and then these are the things I need to do, then let's delve into each of these problems, what are the details, right? So giving a higher level view of my thesis is this, and that has these pieces, and
So
this
you
piece
can-
is done, and these pieces are
Yeah,
done.
so that's what I was saying when talking about Jouler, right? Because that's the part that you finished, right? I wouldn't, like, I'd be careful, I wouldn't describe it as an experimental platform. I think we would argue this is how it should be done, right? Like this is, we have to, in order to respond to the different ways users use the phone, we can't rely on policies that are embedded in the platform, right? They're just not flexible enough. That's your design argument. That's what led to the whole Jouler architecture in the first place. I think you can structure, I think as Kartik suggested, you can structure the talk around that Jouler architecture slide, right? I would put that up, and I would talk about pieces in detail, and I would, like you said, make it very clear, this is what I've done, right? So the bottom half of that is really kind of done, right? We built that, that part is finished, right? And then here's what I'm doing next, right? So moving up and working on the policy stuff, which is I think is a little, like I said, a little juicier, a little more interesting, right? But that's good, that's where you should be.
But what should I cut down? Like if I have to add.
You don't necessarily need to cut down, but I think the initial points to going to Jouler, I think you can run through a little quicker, right? And you should plan on hitting the Jouler maybe around the 3-minute, 4-minute mark or something, and then from that point on you spend a couple of minutes on the overall hypothesis and the pieces and things you've done, and then last 3-4 minutes on, here is my plan. To answer that, the box that has not been done, here are the things I plan to do, and more detail, like Jeff mentioned on what you were doing.
Yeah, it definitely seemed like you were, the policy introduction, by the point you got to that, you were already kind of halfway through a normal talk.
And also there was not a lot in there. You said, I tried this, and I thought I would see the graph, which I've seen before in previous talks.
Actually,
and then,
before we move too far away from the graphs, I had a question about the formatting of the graphs.
the previous one.
These are fine.
Yeah, these are fun.
Those are good.
I like them.
Get those
Further, some of the horizontal ones, of the vertical. Yeah, that one.
So what is that black dot? I don't get.
What are the black dots? Yeah.
Those are outliers.
Outliers?
No, sorry, those are the flyers. So those are the flyer. Normally there would be a bar there, right?
So
It's a box plot. We just tore
the
bar
reason I
into
ask
boxes.
is that those lines are conflicting with the scale lines.
Oh, the top ones. Okay, yeah, I think those were.
Oh, the
not-
ticks up there?
Yeah,
Oh,
the
yeah,
ticks,
the ticks
they're
need to
just
get,
normal
okay,
ticks.
yeah, that's true. On the bottom too. Yeah, there
Okay.
But
should be no-
explain
should
to
be
me
no-
again, so the white thing is the mean, is that what it is,
Median.
right?
Median and then
Okay.
Median
max.
25, 75, and then MapAltlim has some default way of calculating where to put the whiskers.
So
That you
what
should
is
be
the
prepared
black
to
bar?
explain to people, but it's weird. It's like 1.5 times the box width.
Yes.
No, but can you explain to me what the black thing is? I still don't get it.
It's a whisker.
What does
Whiskers
that
of the
mean?
So the whiskers are actually calculated, this is a distribution, right,
Yeah.
for all the users that we measured. So the whiskers are telling you on some level how far the distribution extends.
And that's some percentile?
Yeah, that's the thing. I wish we had just set these to be max or something. I mean, the way MapAltlim calculates them is funny. But again, you need to know what the default is and be able to explain it.
It's 1.5.
Times what?
Oh, yeah.
But I know it's 1.5 something. But
Yeah.
I see. So it's some sort of an expanded version of the distribution,
Yeah.
and the gray ones is the actual distribution, all of it?
The percentile.
No.
What? I mean,
The white bar is 50%.
Okay.
The left of the gray is 25. The right is 75.
I see, 25, 75, and there's some 1090 or something. I don't know what the 1.5.
Yeah, that's the problem. They're not. It's not a fixed point. It varies based on the bars. Oh, why can't I do it that way? I wish we could fix this. Just like this is just the default map on the
I see.
box plot with some formatting changes, but we should fix those.
So you can also just wave it away by saying, just look at the median. I think, so if you want to think of the median user, or come up with a way to have a sentence or two that quickly gets across what you want to get across from that slide, without having to describe the vagaries of matplotlib, right? So you want to make a point and say, look how variant it is. It goes from this end to the other end. The medians go all the way. That's the point.
Right, and
The
you
rest
need
doesn't
to,
matter.
yeah, you could highlight, I mean, you might need to draw sort of a line on that, sort of highlight the median.
Or just take a pointer and show that this goes all the way.
I think, I mean, I've told all my students this multiple times, you can't just plop a graph into a talk like this and expect it to work, right? You need to do a lot of work to explain it. If you want it to work well, right? You need to put callouts on there, you need to highlight things. You know, if you have access to the original graphic source, that can be really helpful because you may want to simplify the graph. You usually have to overlay the fonts so that they're readable, blah, blah, blah. So you just can't cut and paste a graph from paper into a talk and expect it to work the same way, right? And it shouldn't. You have a lot, like in the paper, you can't have little cutouts. Like I wish that there were animated graphs in papers. That would be really cool, right? I hit play and it like walks me through the graph and helps explain things, right? But in paper, you have to rely on someone staring to do that. In talk, you can do it. So take advantage. I think the problem with these graphs is they're better suited to a paper. In a talk, people are going to get drawn into these little nits about them and miss what the broader point is, right? And so, you know, that's why when I use graphs like this, I like to, again, sort of try to walk people through them on the slide. And then when you're done, just put a big takeaway message on the top. I mean, you've got it down there, but it's so small, right?
Yeah, the fonts.
Yeah, exactly. And it should cover the graph, because at that point, your message to the audience is, this is the point, right? Like here, I did an experiment, I got some data, I'll show you a couple features of it, and then wham, right? Like this is the takeaway message from this graph. Here's what's important.
Yeah, also describe, again, we said you should cut short on these parts, but you have to describe what background consumption percentage. Like I think I got it now, which I think the total energy consumed by that app versus how much it spent in background, is that what?
Yeah, background by total internal.
Yeah, so you say that and say, look at how variant it is for different applications. It could be as low as 10%, as high as 80-something% on the median for all the users we've looked at. And that I get. You point to it a couple of times, 2 sentences, and then you're done with this slide. And of course, you have the takeaway message in big bold letters.
Right.
You don't need to worry about the vagaries of matplotlib and how it looks and so on. Right?
And yeah, just like, you need to know what these graphs are trying to say in the context of your talk, right? I think, you know, I don't know. I mean, maybe I just sort of assume things, but I mean, I think some of this stuff is not stuff that you really need to bang on too much, right? I think people are gonna agree with this, right? I mean, no one would expect something like this to be super consistent across all apps or super predictable. So I've never considered these to be like really outrageous claims that you're making that you need to back up carefully with a lot of data. I think people believe this, right? It's nice that you have data to show them, and that's important, right? That you're being a scientist and measuring things or whatever, but I just don't think you need to really like dwell on all the diversity. Like, people get that.
The problem is that in the review, half of the things that I thought they know, they said that it's not intuitive, the diversity really, and so they...
Okay, well maybe I'm wrong. I mean,
this data I think is interesting to me.
You and I have
yes.
sort of like been locked into this, and so we know this stuff, right?
Yeah.
But you might be right. I mean, if that's what the review said, then address it. But again, address it like crisply, right? I mean, you don't want people to get confused about the slide.
Yeah, and the same goes for the other graphs you have.
Yeah, I'll work
Right.
on
Yeah.
this.
But I think, you know, I think if you start off, you make the case for diversity between apps, users, you know, devices, whatever, right? And this is sort of what makes energy management so challenging, right? Then you throw up Jouler and you start talking about the architecture, talk about the parts you built, and then talk about the harder parts. And more interesting stuff about value estimation, things like that, right? I do think, I mean, I don't think you made it it didn't make the point is you have, I think I would be careful with some of those examples that you've used in longer talks because they're a little bit more appropriate when you have more time. But one point I think you really want to hammer home is the fact that, you know, to some degree, the fact that we've made so much progress in energy measurement is, I think, sort of biasing the approaches to energy management, right? It's kind of like we've created this hammer and now everybody's trying to use it. But you know, and the simplest way to point that out is just to say, you kind of use that example, but I think that needs to come through really clearly, right? And that's where you motivate trying to estimate value and stuff like that. You cannot make decisions about energy management based on energy measurement of an app alone, period. Right? And if you do, it ends up being bad, right, in many cases. It's really impossible to get right. So, yeah, but I would kind of start over. I mean, I think you have enough material in here,
Yeah,
but I think you want to sort of restructure it, and we can talk about it.
Okay, sure.
Yeah, you should, like, we can talk about those papers next time, or never, over the summer. But you guys should read those papers.
Oh yeah, it's very good. I didn't understand.
What are we talking about?
Out of time
Yeah,
and
there
platform
are business
application stuff.
papers all the time. They have this gaming on, so they have this cloud gaming thing that goes on like in a thin client. So they created a system so that it is fast on your mobile client to play these games with high graphic without seeing all the latencies that you usually face. So
Yeah, they
created
basically
lots of
do, they
speculations.
trade off bandwidth for latency, right?
They
So
don't
the
want-
cloud is computing, continuously computing the next, not just the next frame, but like a bunch of next frames, depending on what the user does. So the cloud is speculating about what the next frame is going to look like, and then it sends you everything, right? And the client makes choices locally based on what to do, right? So it's very clever. Again, like a very conscious bandwidth performance trade-off. Like the bandwidth of this approach is like 10 times what it would normally be. But their argument is like, it allows you to eliminate the argument. What's that?
Where is this published?
It's a Moses.
Oh,
It's a little reminiscent of a speculative
Execution.
It's exactly speculative execution. Right? It's basically speculation for games. Right? But there's a bunch of kind of sort of tricky, clever things that you do to get to it. And it's nice. The other paper that I sent out is this flip-flop application paper, and that paper is hilarious. It's like such an elegant idea. Right? It's a very, very cool idea. So what they do is they say, look, you know, there's been all this work on cloud offloading. It's very hard to get right to figure out when you send things to the cloud to do. So I maintain a replica. I maintain an app on the phone. I maintain an app on the cloud. I deliver inputs to both of them, and I essentially deliver network traffic to both of them. And they just allow them to race continuously. So, and whichever one is ahead at any given point, has made more progress, is actually driving the display, right? So, for example, when it's network heavy or CPU heavy, the cloud tends to get ahead because the cloud has better network connection, better CPU, so they run. And then the mobile app will catch up, and when it's input driven, right, because the inputs take longer to get to the cloud, the mobile app is ahead, right? So again, conceptually, like really elegant idea. Like they barely got it to work. Right?
I mean, it's like any other code offloading ones though. Byongdong did the same thing, right?
No, they don't do the same thing. It's
I mean, same thing meaning conceptually, they just send parts of it to the cloud.
no, but they don't, that's the point, they don't send parts, they send everything. That's their improvement. They say, we're not gonna make a decision about what parts to offload, because it's very hard to do that. We maintain 2 complete replicas at all times, right?
Sounds like something we could go ask for that once that's in
Well,
place.
read the paper, because again, like you read the paper and you're like, this is an awesome idea, and clearly they thought it was an awesome idea because they spent 4 years building it and they barely got it to work, right?
That's the thing with all these code offloading things. Like,
No, this one is the most brittle I've seen by far, right?
No, but
They only
Byongdong-
evaluated on like 4 or 5 apps because they acknowledge in the paper, basically almost never works, right? Like,
I mean,
these were the apps
Byongdong
that
thing is also, they took like 2-3 years, all this thread migration, it's just really hard.
Yeah.
I mean, I don't see.
This was just a mess to get to work. So, but it's really interesting because either they just did it wrong. Like part of me kind of feels like they chose the wrong place to divide the interfaces up, and that just ended up being a mess. Because it's a very, like I said, I think it's a very elegant idea.
Something seems like it would be better at the developer level. I mean,